Today we're going to start my favorite unit of the entire school year, Trig. I love Trig. I feel like Trig is just so important in pre-calculus next year, and I just think it's a lot of fun. So what we're going to do today is just explore the basics of Trig and review things that you have learned in the past and to some extent. So in geometry, you learned about the basic trig functions. Sine, which we label sin, not pronounced sin. Please don't do that next year, say sin. The cosine, which we label as cos, and the tangent function, tan. We also study the reciprocal functions as well, and we're going to introduce those to you today. There is the cosecant function, labeled CSC, the secant function, labeled SEC, and the cotangent function, labeled COT. Now, if you remember, when we use right triangles and we try to find the ratio of the sides, we use the expression SOHCAHTOA to help evaluate these different trig ratios and set them up. Now, if you guys remember, S goes with sine, and that's when we find the opposite side over the hypotenuse side. Cosine is when we find the adjacent side over the hypotenuse side, and tangent is when we do the opposite over the adjacent. Now, that's what each of those labels mean. The O is for opposite, A is for adjacent, and H is for hypotenuse. Now, be careful because theta, which is our angle, so you'll see this notation if you haven't seen it before, it's pronounced theta, can move around the triangle. So if it's down here at the bottom, your opposite side obviously is going to be the side over here, and your adjacent side is the side that touches that is not the hypotenuse. So this would be adjacent to theta, and then the hypotenuse is always going to be that longest side length of the triangle across from the 90-degree angle. Now, if theta were at the top of the triangle, I'm not going to have you rewrite the whole work, but if we had theta up here, notice that the hypotenuse would stay the same, but the opposite and adjacent side would flip for angle theta. So you have to be careful in homework and in notes. If they tell you a specific angle, make sure you're at that angle when you're finding the ratio of the sides. So if you are asked to find the 6 trig functions of the angle theta, if you're asked to find the sine of theta, you know that that's going to be that opposite over the hypotenuse side. Now, the reciprocal function that is new to you is the one that is to the right of the sine function, and that is the cosecant function. This is just the reciprocal of the sine, so it's the hypotenuse over the opposite side. Now, I always tell my pre-calc students, and if I have you next year, I'll tell you the same thing, that the S never goes with another S. It goes with the C. So S goes with C, and that'll be helpful with the next trig function as well, because the next one is cosine, and as you guys maybe already know, that's the adjacent over the hypotenuse side. This reciprocal function is the secant function. So all you do is you just flip the cosine. So you would do the hypotenuse over the adjacent side. Now, again, the C doesn't go with another C, it goes with S. So that'll help you to remember, hopefully. And then finally, our tangent function is the opposite over the adjacent side. And its reciprocal function is the most obvious, tangent and cotangent. I mean, that's very hard to mess up or very easy to I don't know. English is really easy to mess up, apparently. But that would be the adjacent over the opposite side. So, yes, you can have an animal. So that is how you find these different trig ratios. So we're going to practice with some actual numbers. So what's going to happen is you're going to be given an example or a problem, and the problem will ask you to find the sine, cosine, tangent, or maybe the reciprocal functions of certain angles from that triangle. Now, the first thing you want to do is make sure that you have all side lengths of the triangle. If you are missing a side length, come up with a variable to name that side length. I'm going to call this side C because it's across from angle C. You'll learn in pre-calculus next year that we always label the side opposite the angle with the lowercase of that angle. So with that being said, if I want to find side length C, I'm going to use the Pythagorean theorem. C squared plus 4 squared equals the hypotenuse squared. And then you need to simplify for C. So we're going to find C squared plus 16 equals 49. And then we can subtract 16 from the 49. So that's going to give us 33, I believe. And then we would take the square root, and we would get that C equals the square root of 33. Now, some of you might be saying, what about the plus or minus? But remember, we're talking about the side length of a triangle, and that would always be a positive measurement. So we're going to keep that as the square root of 33. Now, when you're doing the problem and you look and it says sine of some angle, you need to pay attention to what angle. For these first 6 questions, they have us look at angle A. So if I said find the sine of angle A, that is the opposite over the hypotenuse. So, and if you even need to put like SOHCAHTOA, you can do, you can kind of do that on your sheet, whatever helps you. I know a lot of people, say that expression SOHCAHTOA. Even as a teacher, I still am like SOHCAHTOA. So with the sine, you're going to find the opposite side over the hypotenuse. So that would be 4 over 7. Now, every time I'm asked to find both the original trig function and its reciprocal, I go straight to the reciprocal next. 4 over 7, just flip it, is 7 over 4. Now, for the cosine of angle A, that is the adjacent side over the hypotenuse. So you're going to get root 33 over 7, and then the secant is when we just flip that. So again, just note that cosine and secant go together. C goes with the S. And then finally, tangent is our opposite side. So look opposite of angle A, that's 4, over our adjacent side, root 33. And then we can flip that for the cotangent and get the root 33 over the 4. Now, for angle C, let me use a different color. These 6 questions, we're now looking at the other acute angle in the triangle. Now, if you look at angle C and I say find the sine of angle C, note that the opposite side this time is going to be the root 3, and the hypotenuse is going to be 7. If I ask you to find the cosecant, you just flip it. Cosine of C is your adjacent side, 4, over your hypotenuse, and then flip it for the secant. And then finally, the tangent of C is going to be the opposite side over your adjacent side, and then flip it for the cotangent. So that's pretty much finding the different trig ratios. One thing that you're going to learn in pre-calculus, and I'm going to show this to you guys now, is this idea of rationalizing the denominator. Whenever you have a denominator that has a radical, right here, right here, right here, and right here, in pre-calculus, we talk about rationalizing the denominator so that radical moves to the top. I want to show this to you guys now. We don't require it for this class, that you know it, but I want to show you because I do think it's so important for next year. What you do is you just multiply top and bottom by the radical that's down in the denominator. When you multiply across, you get 7 root 33, and then remember root 33 times root 33 is just 33. So this would be the final answer rationalized. Again, we're not requiring that you guys do it, but I do think, as I said already, it's so important for you guys to see. Same thing with this question here. You would just multiply by root 33 over root 33. So you would get 4 root 33 all over 33. And then for this one right here, same thing, just multiply by root 33, and then you would get 7 root 33 all over 33. So you're going to see those same ones down below here. You'll see that over here, the one that we didn't finish right here, is going to be the same thing as the tangent of A. So if you were to rationalize, this would be the 4 root 33 all over 33. So just kind of showing you guys something that you'll need to know for the future. Moving on to the next page of notes. The next page of notes is why we need SOHCAHTOA. So this allows us to find side lengths of missing triangles, but then also find angles. So the first and most important thing is that our calculators need to be set to degree. So if you guys could please open up your calculators. If you can take out your calculators, let's try that again. And if you guys can go to your mode button. So if you guys turn on your calculator, there's a button on your calculator that says mode that's right up at the top by that second button. And you need to make sure you are in degree mode. So what you'll do is you'll hit enter for that and then go to your home screen. Now, when we do these problems, because the angle's in degrees, we want to make sure it stays in that mode, and it shouldn't change unless you change it. So before we actually type anything into our calculator, what we need to do is we need to set up a ratio from SOHCAHTOA that can help us find this missing measurement. So first things first, I have this angle 24, and I know that this side right here is the side adjacent to 24. And I know that I want to find x, which is the hypotenuse side. You need to think about all of your trig ratios and think which one has h and a from SOHCAHTOA. Well, SOHCAHTOA, if you guys remember, the ka is the adjacent side over the hypotenuse. So what we're going to do is we're going to say that the cosine of 24, notice I'm not saying angle A or angle B. This time I can actually fill in the angle, the cosine of the angle 24 degrees equals the adjacent side 31 over the hypotenuse side x. Now, once you get this set up, we can just solve for x. Well, to get x out of the denominator, we need to multiply both sides by x. But then to solve for x, let me rewrite this. We need to divide both sides by the cosine of 24 degrees. I always like to do all the math first before I go to my calculator. Now, in your calculator, you are going to type in 31, and you are going to divide that by the cosine of 24, close the parentheses. You don't have to put degrees on there because your mode is changed to degrees. So as long as you did that correctly, you should get something of approximately 33.9 as your answer. And if we have units, we would put those units in, but since we don't, we're going to leave it as 33.9. Now, note that the hypotenuse should be larger than that adjacent side. If you guys remember, hypotenuse is always the largest side, and our math confirms that. So it's a great way, knowing things about triangles is going to be very helpful. Now, looking at part B, you are going to do the same thing. If you want to try to pause the video and see if you can kind of set this one up on your own and then resume it when you're ready to go, that'd be great. You can even try to solve it all the way if you think you know what to do. So let me walk through the work for this problem, whether you pause the video or not. I have this angle 58, and the side across from it that we want to find is the opposite side, and we are given the hypotenuse. Now I'm looking at the O and the H, and I am seeing that this is the sine ratio. Sine is the opposite over hypotenuse. So I'm going to say the sine of 58 degrees is equal to the opposite side over the hypotenuse. Now this one's a little easier because to get x alone, if I just multiply by 18, that's getting x alone. So in my calculator, I could just do 18 times the sine of 58, close those parentheses, and I am getting that x is approximately 15.3. Again, another problem you can check. Does that make sense that that measurement is smaller than the hypotenuse? It does. So we're good on that. So the final two questions, and then we are done with the notes for today, is finding angles. When you are solving for a missing angle, we use the inverse of the appropriate trig function. You guys might have noticed above the sine button, cosine button, and tangent button, there's words that look like this, and it has that same trig ratio with the -1. This means you are finding the inverse of that trig function, which means it's going to tell you what the angle is equal to. So you only use these inverse buttons when you're finding angles. Now, in order to do the problems, you're still going to start off the same way. Think about angle x, that's what we're trying to find. We know the opposite side, and we know the adjacent side. So think of your trig ratios, SOHCAHTOA. Notice I don't use reciprocal functions because they're not on my calculator. So if you're wondering that, like, why wouldn't I say cosecant or any of those, it's because they're not on the calculator. So I know opposite adjacent. I know that that's tangent. Tangent is the opposite over adjacent. I could highlight this too, just to be consistent with what I've been doing. So let's set it up. The tangent of x equals opposite over adjacent. Now, to find angle x, we don't divide by the tangent. What you're going to say is that x equals the tangent inverse. Can you guys please turn that down? They're watching Trolls, I think. Tangent inverse of 30 over 18. Okay, they didn't hear me because it's so loud that they can't even hear their mother yelling at them. So we get x is approximately 59 degrees. So that is how we'd go about finding the angle. So let's do one more of these. Again, if you want to try to pause the video and try it on your own and then check to see how you did, feel free to do so. So this is how you're going to solve this one. You are going to see that x is up on the top, and we have the adjacent side and the hypotenuse. So looking at the a and the h, I am thinking cosine on this one. So I'm going to say that the cosine of x equals my adjacent side over my hypotenuse. So x is going to equal the cosine inverse of that ratio. So using my calculator, I'm going to do second, and then that button that says cosine, because above it is the cosine inverse, and I'm going to type in 30 divided by 50. Now, if you reduce 30 divided by 50 to 3/5, great. It doesn't matter if you reduce or not, because in the end, you get the same exact answer. You should be getting an angle of approximately 53.1 degrees. So those are the notes for today.